welcome to another tutorial for EWM MFS. My name is still Hendrik. Welcome to a new video of the series SAP EWM Meets Automation. This is a video series with tutorials in and about EWM MFS. And with this video, we are going to unwrap the warehouse monitor and especially the MFS node and its subnodes in the warehouse monitor. So I will look into the content as well as the methods of the MFS part of the monitor. There is a lot of stuff available given by the SAP documentation. I promise to add some value here, provide some more details that you will not find anywhere else. I expect from you some base knowledge about SAP EWM MFS. I would recommend to watch the introduction videos. I will link them here in the video and in the video description because I won't explain the basics here again. So if I mention terms like communication points and telegrams, I just expect that you know what I'm talking about. There is a blog as usual, and the blog has all the technical details. That means all the objects, all the function modules behind the nodes, all the methods, all this stuff. I will not mention every technical detail here, but you will find everything in the blog, which is also linked in the video description. Having said that, at this point, thanks a lot to the Swisslog EWM team. As usual, provided valuable input here, and they're happy in case you get in touch with them via the social networks or via the website, which I will also link in the description in case you need help in and around your EWM MFS projects. That's all for the introduction. Let's jump into the details right away. In order to avoid a 1-hour video, I splitted that one into 2 parts. So with this video here, we will be talking about the nodes starting with the communication channel up until handling unit. And the next video, which will be released in around 4 weeks from now, will then tackle the remaining nodes, so handling unit up until the telegram buffer. For those of you using EWM MFS, this might look familiar or it might not look familiar due to the fact that usually the service provider or the subsystem vendor which configures and sets up your MFS will probably add some custom, some Z nodes. I doubt that there is any EWM MFS project running purely on the standard nodes, so this might look a little bit different. Don't get confused, this is the standard. Good. One by one, let's go through a walk across the MFS node of the monitor. And as I said, we start here with the communication channel, and the data displayed in the grid is basically the content of table SCWM MFS CCH. And this is the table which holds the application master and customizing data of the communication channel. And in addition to this, we have methods here, 4 in total, and the first one can be used to start the channel. So that basically opens the socket to the PLC and enables the communication, and that's either an RFC-based communication or TCP/IP-based in case you're using ABAP push channels. And using the method here, it just updates the status in the table that I just showed you on the previous slide, and then schedules this background job, this MFS period check background job, which frequently, regularly checks, for instance, whether there is any telegrams in the buffers which are to be processed, or whether there are any tasks which are to be sent to the subsystem, and so on. If you want to get details about this background job, I would recommend to check this video about the communication between EWM and the PLC. I will link it here in the header of the video. The second option is here is to stop the channel, and so you might imagine already that closes the socket, so that disables the communication via this channel with the PLC, and again this updates the same status here in the table which holds the communication channel data. And so with this stop here, there is no further communication possible. That speaks for itself. I reset the send or receive sequence number, for instance, in the context of troubleshooting where you have some issues with the communication with the subsystem, or in the context of like initial tests and updates. This might be needed. Usually later during production, this is not needed in the daily business, daily work. Okay, right away to the next node, which is the communication point. And this node summarizes the communication point customizing and the application data, which is basically the storage bin assignment. So here you see in this small part on the screenshot here on the right, you see customizing like whether it's an I point, whether it's an end point, the clarification, communication point, and all those things. But you also see the storage bin, which is application data of the communication point. And this is assigned here in transaction MFS CP, and all the customizing is sitting here under the MFS node in VS Pro. Good. What methods do we have here? First of all, we have the option to set an exception. So if you set an exception from here, this communication point can no longer be used by MFS. So MFS won't send any task for HUs moving from or to this communication point. The status request, that's a possibility to send a telegram to the PLC asking for the status of the communication point, and the PLC will then send the response. Here you see an example of such a communication. In this example here, the first telegram is a GRQ, which is a status request from EWM to the PLC, and the PLC responds in this example with a GSR. The wording and the convention and the telegram types here might be different in your project. This is usually depending on the subsystem and the type of protocol that the subsystem vendor brings into the project. Last point here is trigger telegram processing, and with this method we call MFS WT-det-prep function module in the background, and that function module here explicitly checks for the given communication point, so the one that we marked before we called this method, whether there's an HU standing at this communication point having an open task which has not yet sent to the subsystem. So in the basic videos here we talked about this KZ sub status in the warehouse task, which holds the information about whether telegram has been created for the task or not, and whether it has been sent to the subsystem or not. And with this method, the EWM checks whether there is a task for the given HU on the communication point and whether this task can be sent to the subsystem or not. And if it's being sent, then this is done via the function module SAP EWM MFS send. And here I do also have a video with a lot of details. I won't go into detail here, but there is a communication related video which I would recommend in case you want to get more details here. Good. Next one, very famous node, is the telegram node. And as the name says, this node shows the telegram, so it shows the data string which is being exchanged between EWM and the subsystem, either an outgoing or an incoming telegram, along with header data like the PLC which sent or received the data, and the date and timestamp, sequence numbers, and things like that. Yeah. And the buttons here at the top that can be used to show either the warehouse task which corresponds to the telegram in case there is a warehouse task. It does not necessarily have to be the case, or it shows the application log for a specific object. So if the telegram is about an HU, like moving an HU, handling an HU, then system displays application logs for the HU ID in the bottom grid here, and the same is true for the warehouse order. And the application log for the time is just selecting plus minus 5 seconds from the telegram processing time and shows the application log from this period. We also have two methods here. So with the telegrams that we send, we can trigger resend. Yeah, this is obviously not possible for telegrams that we received, but with this method here, we can call again function module SEWM MFS send in the background, and that just resends a telegram to the subsystem. Yeah, and with the simulate telegram option, we get a small pop-up, and with this pop-up we can adjust the telegram, either the one which has been received or the one which has been sent, and change some data and then receive or send again. This can be done here with this second method. The buttons here I mentioned already, and thus we can skip that here. Maybe just one small remark for the application log. There is a pre-selection for the log object and the sub-object here, WME and MFS, so it does not show you the whole application log, narrows it down based on the objects here. Good, then what you saw here, this button on the right, the APC TCP log, this is a kind of special technical stuff, so in case you're using ABAP push channels, that can be used to analyze what actually happens on the level of the TCP/IP communication. Don't want to go into detail here, that's going to be very technical, but in case you're interested in all those details about the log for this kind of communication, I would recommend you to read the documentation of function module read_tcp_log, or the corresponding report. Both have the same documentation. Or there is a zap node that I found, and this zap node 2258103 that shows some more information about how to read the TCP log files. Having said that, there is also a separate node actually for the APC TCP log. And this node also has a button then to show the application log of the time period where the APC TCP log was created. And here again, when you push this button, there's in the background a selection that takes ±5 seconds from the APC TCP log and then selects the application log for the WME object with sub-object MFS. That was this node here that you see on the left. I missed to include the screenshot, but APC TCP button in the first place was available in the Telegram node, and then there was a separate node for the ACP TCP log itself. But now we are in the warehouse task node, and the warehouse task node shows us all warehouse tasks which are relevant for MFS. And this is not based on KZZAP, this ORDIM-O KZZAP field here, but rather based on ORDIM-L WT code. I didn't check in detail where this is being set. I assume that is always set when the source or the destination of the task is the communication point. Anyhow, for you, that you understand it, with this node, EWM does not show like the same warehouse tasks that you would, for example, see in the document nodes here. This is narrowing down for MFS relevant warehouse tasks. For those warehouse tasks, you can then provide additional details, but those methods here, the whole list is just reflecting this hotspot feature that you know from other nodes of the warehouse monitor. So if you just put, let's say, push the product method, it opens the product master data, and if you check the source HU, it opens the pack transaction with the HU details, and so on and so on. No additional features given here. Next one and last one for this video is the handling unit node. And for this node, EWM selects HU from MFS relevant storage types. So this is based on the customizing the storage type role that you can set there, and then selects all the HUs on bins in these storage types, which are also assigned to communication points. So it does not show all HUs, for example, in the ASRS storage type. Then you would have a list of I don't know, 50, 100,000 HUs here, but only for the bins which are assigned to communication point. And plus, in addition to that, also HUs which are being moved from or to one of these storage types or communication points. So for example, HUs which are just being moved out of the RSRS or into the RSS, for instance, with the cranes, for instance. Yeah, I showed you, I included some screenshots from the coding here. So this is the selection of the relevant storage types here, and in the middle you see the details. So here, this is the constant, which is holding the storage type role, and with this constant we are selecting from the T331 table, and with those storage types we then try to get the HUs which are moving from or to the communication points. This is done here then with the HU selection. Methods provided in this notes are first of all the option to set an MFS error, and this option will write into the HU header field MFS error, that one here. And if you have written an error in this field, then with the processing of the next telegram, so the next warehouse task by EWM MFS, this error code will be considered and the HU will potentially be routed to a clearing communication point or outfeed, for instance. Yeah, so if you have a HU sitting in the middle of the conveyor somewhere, you want it to be rejected, then you can set an error here, and then the standard logic will make sure to route the HU via the error communication points towards the clearing communication point or outfeed. This is a useful method. The second method here is triggered telegram processing, and here we have two possibilities. Either the HU is sitting on a communication point, then again EWM checks that whether for this communication point there is a warehouse task which has not been sent to the subsystem yet, and whether this task can be sent or a telegram can be created and sent via MFS send function module. And the second option is the HU is on a resource, and in this scenario MFS checks whether the queue of this resource has a task, or whether the next task from this queue can be processed, and whether a telegram can be sent for that task to the subsystem. Create warehouse task, this is simple. This just opens the add-HU transaction, and then for this warehouse task you can create a HU warehouse task to move the HU from the current position to another one. And as promised above, I splitted this video to keep it a bit shorter, and what we did now was a quick but deep review of the nodes communication channel up until handling unit. As I said, the second video will tackle the nodes handling unit move up until the telegram buffer. And what you can see already now is that with the MFS node in the EWM Warehouse Monitor, you have access to the customizing application and master data of the MFS objects, like the communication channel or the communication point, for instance. The same is true later for segments group and all this stuff. Resources, we will see that in the next video. Second thing you should keep in mind that you have access to transactional data, like telegrams and HU movements, so you have the option to monitor the data or to analyze. And the third important thing that you should take away from this video is that you have the option to set exceptions. That's probably the most important feature here. So set exceptions on the communication point or on the HU, and then based on this, for example, in the context of troubleshooting, then stop processing for a given communication point, or reject an HU, or even stop a communication channel in case you want to stop the communication completely here. That's also a kind of exception, although it's not called that way directly. Good. I mentioned that before. The technical details, all this stuff is in the blog. Most important thing right now is that you subscribe to the channel so that you will be notified in case I release a second part of the Warehouse Monitor review, and that you visit the website of the EWM team at Swisslog, as they will be very happy to show you what they have over there and to help you in your MFS projects. Having said that, done for today. Hope to see you again next time, and bye for now.